Welcome back. Today we are going to talk about the centered sum of squares and cross products matrix, or CSSCP. I went ahead and wrote down the formula for variance here. As you notice, variance is the sum of squared deviation scores divided by the degrees of freedom. Covariance is defined as the sum of products of deviation scores across two variables, we have x and y here, divided by the degrees of freedom. Now, as mentioned in video 3.6 on matrix multiplication, we've got sums of products here in the numerator of the covariance formula. So once again, this is the sums of products. And with variance, we've got the sums of products or the sums of squares because it's the same variable. And to demonstrate that, variance is the covariance of the variable with itself. We can just say we have covariance here over the degrees of freedom. If you use the same variable, so use instead of y, use x again, so x times x, you'll just get the variance. So you could say that covariance is just a special type of variance, or variance is covariance of the variable with itself. Now let's use a set of deviation scores we obtained in video 3.2. Remember, we had a matrix of 5 observations and 2 variables in which we subtracted a matrix of those 2 variables means from it to obtain the deviation scores, and we labeled this matrix X. So if you recall, we had X, 5, 2, negative 2, negative 2, negative 3, and on the second variable, 6, 0, negative 2, negative 3, negative 1. You pre-multiply this by its transpose to get the sums of squares for the 2 variables in the diagonals of the resultant matrix, and we will call it B. So let's have a matrix B here. And once again, you pre-multiply this by its transpose, so the transpose would look like this. Okay, multiply it by our x here. And the resultant matrix will turn out to be 46, 43, 43, 50. So as you see, this is a 2 by 5 matrix, and this is a 5 by 2 matrix, so the resultant is a 2 by 2 matrix. And once again, we get the sums of squares for the 2 variables in the diagonals, so 46 and 50, which the sums of squares, once again, is the numerator in this variance. And in the off diagonals, we get the numerator from the covariance, which is the sums of products, which, once again, since covariance is just the variable with itself, you get the same number, 43. Now this is called the centered sum of squares and cross products matrix. Centered just means it's created from deviation scores, and cross product is just another word for the sum of products. It's centered from deviation scores and contains sum of squares, variance, and sums of products, the cross product or covariance there. And remember, that's just the numerator that we circled here. Later on, we'll demonstrate how to get the actual variance and covariance. by dividing by the degrees of freedom, which is n minus 1, and we will get what's called a covariance matrix. So I just want to reiterate, once again, this is the CSSCP centered sum of squares and cross products matrix that we formed here, which is necessary to get our covariance matrix. Now let's talk about this in regards to Excel. So let's go over here to Excel and enter our variables for x. We have 5, 2, negative 2, negative 2, negative 3. Oops. And then 6, 0, negative 2, negative 3, and negative 1. Okay, so as you recall, we pre-multiplied that by its transpose. So let's copy and over here do a special paste, transpose, to get the transpose. Once again, I should label this over here CSSCP equals MMULT, because this is matrix multiplication, open parenthesis. We're first doing the transpose, comma, this. And before you do anything, before you hit enter, make sure you do Control Shift, and then you can hit enter. And we get the same values as we did over here, and this is our centered sum of squares and cross products matrix.